actual SGA. So SG is a memory of database. So apart from the background process, there are many things Oracle does. Oracle database is responsible for storing files on the data files on the storage area in the form of tables, objects, indexes, functions, triggers, and in that form. Apart from that, it is also responsible for managing your request. It could be DML, DDL, data manipulations like updating the existing table, inserting new records, deleting the older record from the column. Also, it is responsible for giving the results. Like sometimes you can go for select query, you want to fire a query, select star from table where employee name will display. So all these things are done under the SGA, name is System Global Area. The system global is defined in such a way that all the requests, whether it's for update, if you're updating something, it will go to different part. If you're just selecting, putting a query for select star from the EMP, just a normal query, select query, it will go to different part. Now, also at the same time, it have to maintain a consistency of the database. Example, now some user is updating a table, and while performing update, the database got crash. So the database role is also to make the database in a consistent manner, so that next time somebody query the table, it should show either the consistent data or it shouldn't show any kind of update to the table. Same time, it has to make a process that every after, like if there's a huge number of records being updated, it have to mark, like after 1/4 of the record is updated, it has going to mark that this record has been updated to some of the file, so that at least, because the thing is that before and after, you might have another rollback. So when you update a table, before and after image copy of the data is captured in the database buffer cache or in the Oracle database, so that if somebody roll back the changes made to database, previous changes can be shown back and the new changes will be wiped out from database. So we will understand this one. Okay, then let's understand the first background process. What is DBWN? The name itself says ki database writer. It's a database writer. So maximum 20. So by default, one database writer comes with the fresh database, and you can configure depending on the size of your database and also number of transaction, number of IO your database performs. If your database is a company's database, it's a very huge, which perform huge number of transactions on a daily basis, have a huge number of IO. In that case, you would need more and more database writer. So you can configure, you can increase, you can decrease, but by default, at least one should be up and running. Whenever lock switch is occurring in reader lock, the file is becoming current or to active stage, Oracle calls DBWN and synchronizes all dirty blocks in database buffer cache to the respective data files, second or randomly. Database writers or dirty buffer writer process does multi-block writing to disk synchronously. Disk means the storage area where your data files are available or your database resides. Synchronously, one DBWN process is adequately for most systems. Multiple database writers can be configured by initialing parameters db_writer_processes defined on the number of CPUs allocated to an instance. To have more than one DBWN only makes sense if each DBWN has been allocated its own list of blocks to write to disk. This is done through the initialing parameters. DB_block_LRU_latches. If this parameter is not set correctly, multiple DB writers can end up contending for the same block list. The possible multiple DBWN process in rack must be coordinated through the locking and global cache process to ensure efficient processing is accomplished. Now let's enter what is DBWN. Now, when a user performs any kind of task like update or insert, I would say insert. delete. Now this is database buffer cache. It's a cache. So your request will be handled by database buffer cache. Now database buffer have a memory. It have a huge number of, it have a records, like the way it depends on the size of a database buffer cache. Now you have somebody have inserted delete and somebody have also used command like select star. Yesterday we have discussed select, that how the select query works. Now you have entered select star from emp, and now you are the only one who have select star from emp. Now that data is put in a buffer cache. Now, after specific time, nobody have used that query. So that memory will be removed. That memory will be, or data will be removed from database buffer cache. Now that will become as a dirty buffer. Also, when you insert or delete something, it goes to your database buffer and it have a specific size. Like this is my database buffer cache. Now it keep, like every time you perform any kind of actions, the memory gets allocated. It directly, when you perform any kind of actions, it doesn't go to your data files. This is my data files. Data files which have .dbf. When you perform any kind of action, this won't go directly to data files. First, it will go to the database buffer cache. It will update, or it will hold the query or data with itself, and after it gets full, example, now there are huge number of update or different kind of commands coming on the database buffer, so it have to hold all the records. So it's like least record. Now it will filter out least record, which was the least action performed on the database. Now the least performed action will be called as a dirty buffer, and they will be removed and they'll be returned back to data files. Now delete command, which you have executed earlier, it have holded the data with itself. Now when have it reached its threshold, or checkpoint got occurred. Checkpoint is something which marks the data files in the control log files and everywhere with the consistency database. It checkpoint occurred, it will take the record which have changed and mark or put its records consistent, or put the record to the data files. So all your actions which you have performed on the database won't go to data files immediately, because it requires IO. Because performing any kind of action to your data files, it requires IO, because in that case it have to spend more time, more CPU, more RAM will be required. If it have to write anything to database files. Now data file buffer is invoked when we question, like when it is invoked, when dirty block in SGA reaches threshold value. Threshold means it have some limitation. It might have some example. It have 1 GB of memory. So, and it is holding huge number of records like insert, delete, select, star. There are many things which is happening on the database sites. So after it gets full by 1 GB, automatically DBWS writer, it will go and ask to remove the dirty buffer, which was least used, called LRU, least used, will be flushed off from the database buffer cache and will be returned back to your database files. So with the help of this process, it involves less IO with your database or data files, which brings your system quite more faster. SGA is something which is based on your memory. Memory means RAM. Data file is something a file resides on the storage area. So storage area might be locally available to your database, or it might be mounted with the help of NAS or SAN. It depends how it is mounted. Okay. Remember, DBWN is the only background process which is responsible for writing to database file. So DBW was the process which made this buffer cache to write data files. It DBWN. So because this is the process which have made database buffer cache to write to the data files. Okay. Apart from this, we'll go now understand the whatever. When the database is shutting down, normal transaction immediately with some dirty blocks in the SGA. Shutting down, like when suppose you're writing something, inserting, deleting something, okay, and suddenly somebody have executed shutdown immediate. In that case, it have to mark consistency of a database. So what it will do, it will go and to the database buffer cache and it will mark all dirty buffers to your files. Now all the records which you have updated earlier, which it was holding with the database buffer cache, will be marked back to your data files or any other files. Now this will make the database consistent before database goes down for your down. DBWN has a timeout value 3 seconds by default, and it wakes up whether there are any dirty blocks or not. By default 3 seconds, and if there are dirty blocks are something which are least used. Least used means a record, somebody have you have deleted some kind of record, but apart from that, nobody have else touched that table, that objects. You have selected a select from EMP. Apart from you, nobody have else done that. If there are a number of record which has been used by huge number of people, that memory or that object will be put in a database buffer cache because it was mostly used. So it is most used, that means it has been put in buffer cache. So next time the database doesn't have to go to database or data files to pull the data. So in order for the performance purpose, your all the most frequently used or less used will be put in a database buffer cache. When a checkpoint is issued, when a server process cannot find a clean user buffer after scanning a threshold number of buffers. When a use table wants to enter into SGA and Oracle did not find in free space where it decides to flush out LRU, least used blocks, and which happens to be dirty blocks. Before flushing out the dirty blocks, Oracle calls DBWN. Oracle rank ping request made when table dropped or truncated. When table space going offline or read-only backup. So these are the checkpoints, or these are the process when the DBWR is invoked and all dirty buffers or anything which is already standing on the debugger will be called or will be flushed off. Flush off means it will remove the data from the buffer cache and it's going to mark its presence or going to make the changes to database files because it has been removed. That means it doesn't delete, it's wipe out means it moves from buffer cache and it put that data in a database files. Now that data is no more available in buffer cache, the data is directly available in database file. Example, now you have performed select star from EMP table. Now your data, which is a local, which is a temporary memory, which is a temporary select star from EMP, has been copied to database buffer cache. Now now that data has been copied, but after that somebody have performed select star from table, from department table. Now again that is available on this one. Now again somebody have done select star from account department. Now there are 3 Now one by one new request is coming, and all the requests like staff EMP, they are not being used at all. In that case, they will be marked as a dirty buffer and they will be removed from the buffer cache. So next time if the same query comes, again the database will go back to database file because that was used very frequently and it was used long time back. Log writer. This is the database buffer cache, shadow log cache, library cache, and addition cache. We will understand what are the other things. But let's understand this DBWR. Now log writer. Log writers redo data from redo log buffer to online redo log files each sequentially. Redo log file contains changes to any data file that the content of the redo file is file ID, block ID, and new content. LGWR will be invoked more often than DBWN as long as files are really small when compared to data files, KB with GB. Every small update we don't want to open hugely gigabyte data files, instead write to the log file. Radio log file has three stages: current, active, inactive, and is cyclic process. The newly created data log files will be unused state. When the LGWR is writing to a particular readlog file, that file is set to be current state. If the file is filled up completely, then a log switch takes place and the LGWR starts writing to the second file. This is the reason every database requires minimum of 2 readlog groups. The file which is filled up now becomes the current. Now we'll understand what is LGWR. Now, this is my database. The database backup was taken at 12 p.m. And after that, the database ran perfectly fine till 2 p.m. Okay. Now, the database ran perfectly fine till 2 p.m. Now, suddenly at 2 p.m., database got crashed. Now, how would I recover database till time, correctly, perfectly fine? Because backup was taken at 12 p.m. So I have no backups between 2 hours, that like between 12 p.m. and 2 p.m. And how would I take the recovery till time? How will I ensure that all my database transaction which have happened till 12 p.m. should be consistent? Because the backup which was taken was at 2 p.m. So what really happens to the redo log file? Redo log file is something which is responsible for keeping the last changes made to the database in redo groups. Okay, it will have record every changes made to your database to the redo log files. So what we'll do in that case, we will recover database till 12 p.m. and after that we will apply the redo logs. Restore last backup, then apply redo logs. So redo logs are something which records every changes made to your database in the form of redo logs. Redo logs. Now my database has files. Now database have parameter files. There are more database files which are called redo logs. Parameter files are SP file, E file, control. These are the files which database require before starting up. During the startup, these files are required. Database files are something which is required for storing your database objects on the storage area. The reason is that the target or the goal of Oracle database is to have less communication or less I/O with the file stored on the storage area, because that requires much of I/O and takes time. And database is something which is a fraction of seconds you should get your data. Database should be faster. So the reason is that like example, you are one user performing a transaction. Okay. Now you made some changes to the database, so like the committed transactions. So just because for you, if it has to go and write those changes to DB files, that might be there might be hundreds of users like you, and every time hundreds of users ask to go and perform a committed and then write to a database file, that means it has to write data to DB file which is available on the storage side 1000 times per second, nanoseconds. that will be huge number of IO will be involved. So database will not have that much of memory to perform its other operations, because database is also working with the help of RAM and CPUs. So what it does, it consolidate all the transaction made changes in the form of reader logs. Okay. And reader log will have some size like 50 MB, 1 GB, 2 GB. When you might have made transactions. So your transaction example I'm giving, like your changes which you have made to database might be for 1 KB or 2 KB or 1 MB. So in that way, unless it reaches reader log file size, it will not go and make any changes to database file directly. So the way Oracle database is designed, that every record which you make changes, it will record it somewhere. It's not going to wipe out. Even the database, before database shuts down, crashes, it will make sure that these record logs are available. So when next time, whenever you start the database, it will read the files, the entries, the changes made to database file from the reader logs. Because database file, it will check from the control file that this is the changes made. But what changes were made will be copied from, or will be copied or made an image copy from the reader logs file. The target of database is to have less IO with the storage, because in many companies, your machine will be, this is my IP address of my machine, like where my database is there. Okay, this is my DB system, this is my database, only database. Okay, not the storage, not these data files. Okay, but in case of be on a safer side for like because data is very important. If the company loses data, that means everything is gone. Okay, they will mount U01, which is my data files storage area. Data files. Now this is mounted to my database. Mounted. Now this will have its IP address. Now, if your memory gets full, then you can ask that you want to add more storage. They will add one more storage area, one more hard disk, and mount it back to this one. Now again, it will mount it. But while communicating from database to storage area, or where the database resides, it have to use network bandwidth. And network bandwidth, again, it have to invoke the local processes on the OS side, take the network. With the help of network bandwidth, it will go right to the database file and again read from it. If it every time if make any kind of changes, if they have to go and write to database files and everything, that means all the memory which you've allocated for database will be completely used for perform this kind of action. So when other things will be done, like the performance tuning, indexing, recreating database files, select querying other database files, so that too takes a huge number of memory and RAM. So in that case, Oracle is designed in such a way that all the changes made to your database are not directly written to database file. Initially, they will be written in data logs file or database dirty buffer cache. So after a threshold is full, in that case, they will wipe off the memory from the dirty buffer cache or data logs, and then it will be returned back to your database files. Over here, you need to understand two things. Two background process, which is very important background process, that is DBWR, WR, and it writes to data file. It writes to redo logs. DBWR will never write anything to redo logs. Sorry, this is LGWR. LGWR. And LGWR will never write directly to database files. Okay. Now you got the point. it's important question, like might be in interview questions. They ask you, can DBWR directly write to log files or not, and will LGWR write to data files or not? So this will never do that. DBWR will never write to data logs file because it is not access to that. But DBWR invokes data, it's a process which gets invoked. Okay, when a checkpoint is occurred, anything like that, and then dirty buffer cache is written back to your database file. But DBWR can be invoked and it writes to database files, and LGWR writes to log groups. So by default, your data, when you install database, you will get data files, reader logs, control files. So this is the actually the heart of the system. If you don't have a reader logs, you can't start your database. The way database files, reader log files, they are very important thing. And archive logs, this is optional unless you don't put your database in archive mode. Archive logs won't be generated, but this is something when you start database, by default, it's there. LGWR will be invoked in following scenarios. Just a moment. LGWR is invoked whenever 1/3 of the redo log buffer is filled up, whenever the log data writes out 3 seconds, whenever 1 MB of the redo log buffer is filled. This means there is no sense in making redo log buffer more than 3 MB. Shutting down database, when you perform a shutdown database, all the redo logs buffer will be written to redo log groups. Whenever checkpoint occurs, when a transaction is completed, either committed or rolled back, then the Oracle calls the LGWR and synchronizes the log buffer to reader log files, and then only passes on the acknowledgement back to the user. This means the transaction is not guaranteed, although we set commit, unless we receive the acknowledgement. When a transaction is committed, a system change number is generated and tagged to it. Log writer puts a commit record in the redo log buffer and writes it to disk immediately along with the transaction redo entries. Changes to actual data blocks are deferred until a convenient time. Fast commit mechanism. When DBWR signals the writing of redo records to disk, all records associated with changes in the block buffer must be written to disk first. The write ahead protocol. While writing dirty buffers, if the DBWR process finds that some redo information has been